Well, it's good to be back with you. I was here, I guess, a couple years ago and talked about how God has built even his creative glory into mathematics, which is kind of neat. This one will be a little more down to earth. Hopefully. Sometimes I just can't resist. We're going to talk about how science confirms biblical creation. And this is something that's very important because we live in a culture where people have the impression that the Bible's been disproved by science. That is very, very common. And in fact, what the secularists do is very clever. They actually take their particular religious beliefs, millions of years, evolution, what have you, and they claim that that is what science says, as if science could say something. But in any case, they present that as if it were scientific. And and so you Christians, you're anti-science, and nothing could be further from the truth, because the Bible, the biblical worldview, is actually what makes science possible. The fact that God created a logical, orderly universe and upholds it in a consistent fashion and made our minds able to be rational, made in his image, and so we can analyze the universe and draw logical, rational conclusions about it. He made our senses able to probe the universe. Science exists because of God and the order he has imposed on creation. But the fact is, I have worked with many, many brilliant people over the years. I've worked with some very brilliant secularists and some very brilliant creationists. And we've looked at the different lines of scientific evidence, and we come to very different conclusions. And so it seems to me it can't be a matter of intelligence if there are intelligent people on both sides of the issue. And it can't be a matter of mere evidence, because frankly, I use the same evidence that my secular colleagues use. I look at the same stars and galaxies they look at. I draw very different conclusions. And so obviously it's not really about the evidence, it's not really about intelligence, it has to do with the way that we're looking at the evidence. We all have a worldview, a way of thinking about things that affects how we understand the universe around us. And so I start with God's Word, the Bible. I'm not ashamed of that. If the Bible really is the Word of God, it would be ridiculous to start with anything else, wouldn't it? And of course, I realize we'll have to argue that that really is the Word of God, and there are other presentations I do where you can see that. But taking that tonight as if maybe there are any skeptics here, you can take it as a hypothesis, if you will. But in any case, if the Bible really is the Word of God, it would be ridiculous to start with any other premise. Because why start with guesswork when you can start with certain truth? But my secular colleagues, who largely reject the Bible, they have their own view of how the universe got started and how it came to be today, and that colors the way that they understand the evidence. And so they're looking at it from man's understanding of the evidence, millions of years, evolutionary ideas. They're thinking in terms of slow, gradual processes producing the kinds of things that we see today, natural processes, natural law. Where those laws came from, they can't say, or why they exist, they can't say, but they think that those laws are absolute and not able to be violated. In the Christian worldview, very different. God created the universe, and he did it supernaturally, which is to say he did it in a different way than he upholds the universe. Some people have the impression that God created and then sort of stood back and the universe kind of operates on its own. That's not really biblical, because the Bible says that God upholds the universe by his power, right? All things are upheld by him, or in him or by him all things consist or hold together. So God is constantly upholding the universe today. It's all supernatural in that sense, but we call it natural when God works in the same way that he normally works. But he didn't create that way. He spoke things into existence, and he's not doing that today. That was then. But we understand there was a fall, the fall of man, and sin entered the world. And so the world is not the perfect place that it was when God first created it. God rightly punished us for our sin. And we have these major events that have happened throughout history. We call them the 7 C's of history, 7 words that start with C, kind of helps us remember biblical history. And one yet to come, the consummation, where God will restore paradise. And that's just because of what Christ did on the cross. Now, my point here is that when I look at the evidence, I'm looking at it through the lens of Scripture, through that history that the Bible tells me is the true history of the universe, and I draw conclusions based on that. And my only goal tonight really is to show you that when we look at the scientific evidence in different fields of science through the lens of Scripture, it makes a lot of sense. It's consistent. Science confirms biblical creation. And there are several different fields of science we could look at. I'm going to look at, briefly, we're going to look at genetics. I'll actually spend the most time probably on that section because it's very interesting, and especially some of the things that we've discovered in recent years. Genetics is the study of how traits are passed on from one organism to the next. And then we'll take a look at information theory, which a lot of people don't know much about that, but it's very compelling evidence that confirms creation. Then we'll take a look at geology, and along with that, paleontology. We'll look at rocks and fossils, and we'll see that they are indicative of creation and a worldwide flood. And so just looking at those three areas, I think it's good for every Christian to know just the basics of science, especially in these three areas, because these are the ones where, well, particularly genetics and geology, where the evolutionists say, well, no, we know the Bible's false because of these fossils, or we know the Bible's false somehow because of DNA somehow. And the details may be elusive, but that's the idea. Genetics and geology supposedly prove evolution. They don't. They confirm creation. And so let's just dive right in with genetics, the study of heredity, how traits are passed on from one organism to the next. And a lot of times in this presentation, I'm going to use dogs as an example because there's so many different varieties of dogs, and it's easy to study the heredity of dogs because they reproduce more quickly than people do. So my first question is, do dogs change? Do animals change? Do dogs change? Do they? Yeah, what do they change into? Dogs. Yeah, you got it. Okay. Yeah, of course. And that's what we'd expect as biblical creationists because God created animals according to their kinds, or according to its kind, or according to their kind. That's a phrase that's used 10 times in Genesis 1. We better take it seriously. There are kinds of organisms. And by the way, people say, well, that's species. Well, no, it's not species. The Bible doesn't use that word. Kind is the same as species. And this is something where I found that many evolutionists actually misrepresent what it is that creationists teach. I've had a lot of evolutionists say, well, you creationists, you believe that God created each species as we see them today. And so you have this misrepresentation of creation, that there's been no change in animals since creation, and that's ridiculous. Of course things have changed since creation, and not always for the better, right? I don't think there were poodles in the Garden of Eden. No, we're going to find that's an effect of the curse, ultimately. My point is, this is a misrepresentation of what it is that creationists teach. We don't teach the fixity of species. Yes, you can get more than one species from the same kind, but they're still the same kind. A group of mosquitoes goes off and lives in a cave for 100 years, and when you bring it back out, it's no longer able to breed with the parent population due to genetic drift, and so it's classified as a different species. That's fine. It's still mosquitoes. It's still the same kind. And according to creation, dogs have always been dogs, are dogs today, and will always be dogs. But you can get lots of different varieties of them, and we'll see how that works. So the true thing, the true principle that creationists would teach is variation within a kind, but we don't believe that animals change from one kind to another. And so I don't believe that birds are related to dogs, but I do believe that German shepherds are related to golden retrievers, okay? Variation within a kind, that's what we expect. And so, and there's been lots of different variations. And we'll see how that works when we study the DNA and such, how you can get all those different varieties. Some varieties have gone extinct, right? Dinosaurs aren't around as far as we know. Some variations within a kind are gone, but the kind remains. Other variations remain. Mammoths, we think, are part of the elephant kind. They're gone, but the elephant kind still exists with the Asian and African elephants, for example. So this is, in fact, what we believe. And we're going to see that with dogs, there's been a lot of variation, but they're still dogs. In the evolutionary view, there really aren't such a thing as kinds, because in the evolutionary view, all organisms are related by common ancestry to a single-celled organism, which itself arose by chance chemistry. That is what evolutionists teach. And so in their view, the change is unlimited and sort of an upward change. You start with the simpler organism, something like a bacterium, something like that. And then over millions of years of natural selection and mutations, you supposedly get every other organism on Earth, plants and animals. According to the evolutionary view, you are related to a turnip. And it's funny. I was speaking to a group of atheists one time, and I used that little phrase. I said, in your view, you believe you're related to broccoli or something. And they said, one of them came up to me afterwards and says, weren't you kind of poking fun at us for saying that? And I said, well, isn't that what you believe? And he said, well, yeah. And I said, well, there you go then, right? Don't shoot the messenger. If it sounds a little silly, maybe you ought to reconsider your beliefs. Don't shoot the messenger. Anyway, to understand genetics, we need to understand DNA. This is a very long molecule that occurs in the cells of your body. It looks something like a twisted ladder. Deoxyribonucleic acid. And on the rungs of this ladder are these nucleotide base pairs, and there are 4 different kinds. And they're always abbreviated by those 4 letters that you see there, A, T, and C, and G. And the A's and T's always group together, and the C's and the G's tend to group together as well. But you can arrange them in any order. You might have an A, then a C, then a G, then an A, or whatever. They can occur in any order in your DNA. And based on the order in which they occur, they actually spell out the instructions to make you. It's kind of remarkable, really. And the reason that you're a person and not a cabbage is you have instructions in your DNA to make a person. A cabbage has instructions to make a cabbage. And aren't you glad you got the better deal on that? So it's just in the same way you could spell out help in Morse code with beads on a rope, so I'm told. In any case, you could spell out information in DNA. Theoretically, you could write a book in DNA. It's a 4-letter alphabet. It's not the same language as English. You'd have to translate it, but it could be done. It's just a 4-letter alphabet, but it's the same kind of thing. And all organisms on Earth use this DNA molecule in their bodies to code the instructions that make them, and they have different instructions, so you get different organisms. I should point out some of our instructions are the same. You do have some of the same DNA as a cabbage. And that's very important because what that means is you produce some of the same proteins and you use some of the same proteins. And that's significant because if cabbage had totally unique DNA and totally different protein structure, you couldn't eat it. You couldn't gain nutrients from it, right? So if God had created all organisms with totally different DNA sets, we wouldn't be able to eat anything except each other. You see, that would be a problem. So there is a reason why God did it that way. But in any case, you have 2 sets of DNA. And every human being does. And so Adam had 2 sets of DNA, Eve had 2 sets of DNA. But all people since then have gotten 1 set from mom and 1 set from dad, and there's a way in which they're sort of intentionally scrambled. So you get 1 piece from mom, you get another piece from dad. And the neat thing about that is it's actually the combination of the 2 sets that determines your traits. And that's why you can have traits that neither parent has, for example, because you got a particular section of the DNA from dad, and you got a particular section from mom, and so you have a person that has unique traits because even though they got all the information from their parents, they have a unique combination. Unless you have an identical twin, you have a unique combination of DNA. And so you can get lots of different varieties of human beings just from 2 people, just because of the ingenious way that God has built in that information into our DNA. In fact, because it's the combination, the number of unique combinations is enormous. Take 1 married couple. From them, just in terms of the genetics, you could get more unique children than there are atoms in the universe in terms of the number of combinations of DNA. So it's a really ingenious mechanism to produce all kinds of different variety in people, and that's why some of you have blue eyes and brown hair and light hair. Some of you don't have hair, and that's all based on all your DNA, you see. And so here it is with blood type, and maybe you remember doing this in school, but if you get the gene or the allele A from dad and A from mom, your blood type's A. That's easy. A is a dominant allele, and then so you have A and then the O. O is recessive, and so the A covers up the O. Your blood type's still A. But if you get and likewise with blood type B, but if you get, the only way you can get AB blood type is to get A from one parent and B from the other, and the only way to get O is to get both O genes from one from each parent. And the thing that's neat about this is if you consider this combination, suppose mom has blood type A, and it's what we call the heterozygous A, where you have the A and the O, and then dad is heterozygous B, the children could have any blood type. They could have A, like mom, they could have B, like dad, they could have AB, which neither parent has, or they could have O, which neither parent has. So you might notice that some of your traits look a little like your mom, some of your traits look a little like your dad, and some traits look like neither of your parents. And you say, how did I get that? Well, the information was there. It's just you have a different combination than your parents. And so I have brown eyes like my mom. I have dark hair, it's fading, but it used to be dark, like my dad. And my sister has blue eyes, which neither parent has. I used to tell her she was adopted, but she didn't believe me. That's because the blue eye, it's more of a recessive type gene, so you had to get the recessive combination from both parents. Here it is with skin color. We basically all have the same skin color, brown, caused by pigment melanin. There's a couple different forms of it. There's one that's kind of yellowish and one that's just kind of a grayscale. And depending on how much you have, and this is simplified, but basically it's how much melanin you have determines, and how it's distributed determines how dark your skin is. And so we all have basically the same skin color. It's just a question of how much do you have. And if you have these genes up here, you tend to have the darker color, and if you're down here, you tend to have the lighter color. And of course, if you're in this box and you get married to somebody in that box, your kids are going to be in that box because the capital letters are the only ones that are available. And likewise, if you're here and you get married to somebody in there, or even here, where you have only lowercase a's available, only uppercase b's, and you get married to somebody in that box, the kids are going to be in that box. But if you're off axis, if you're along one of these lines, for example, if you're here, somebody in this category gets married to somebody in that category, their kids could have any shade of skin. And so, by the way, we think Adam and Eve probably had a combination, something like that. There are other ways to do it, but that's one possibility anyway. And there are places where that still happens today. There are certain places in India where at the same dinner table you have people that are very light and very dark complected side by side. With dogs, you can get tremendous variation. God has really shown his sense of humor and diversity in the different variations you can get in the dogs, because they have lots of this heterozygous genomes. And then what happens is from just two dogs, you can get all kinds of different varieties of dogs. Now, if evolution's true, then that means something like a bacterium, which has some DNA, it's got some instructions in it, eventually became something like a horse, right? Horses are evolved from bacteria, if you believe the evolutionary view. But of course, a horse has a lot more instructions in its DNA than bacteria. It's not just that it has more DNA, though it does, but it has more instructions in its DNA. For example, a horse has instructions to make ears and legs and eyeballs. Bacteria do not have those instructions in their DNA, and therefore they're not able to produce those traits. That's pretty easy. So it seems to me that if evolution were true, then at some point, these bacteria had to gain brand new information, right? They had to somehow gain instructions in their DNA. And I'm not saying that's the only thing that would be required, but my point is evolution can't get off the ground unless you somehow increase the instructions, unless you add brand new information into the DNA, because you have all kinds of information in your DNA that bacteria do not have. Okay, so I'm saying that a few different ways to make sure you get it. That's the real point. Evolution is all about an increase in the information content of your DNA. If you don't have that, you don't have evolution. And that's very interesting because the processes that we know about in nature actually reduce the information in your DNA, or perhaps neutral, but they don't increase it. Kind of interesting. Even processes that evolutionists like to say, oh, this is an evolutionary process. When you study it, it's a downhill process. It reduces information. And I'll give you one example of this. One example would be natural selection. A lot of people think natural selection is evolution because Darwin tried to convince people of that, but it isn't. It's actually the opposite. Natural selection is true. And it is a creationist concept, by the way. Darwin didn't come up with it. He just linked it. He thought if he could convince people of natural selection, they would buy evolution as well. But they're very different because they're in opposite directions. The way natural selection works is pretty easy to explain. And again, we'll use dogs here. And suppose you have two dogs, okay, male and female, and they fall in love and get married. And I do this for kids sometimes, you can see that. But and let's suppose they have a gene for short fur and a gene for long fur, and suppose those genes have a combined effect, which some genes do, so that they both have medium length fur. Now, again, this is simplified, but the basic genetic principles here are true. And so you would imagine, well, some of their pups would get the short gene from mom, the short gene from dad, and they would have short fur. Some pups would get the long gene from one parent, the short gene from another. In fact, 50% statistically of the offspring would have that combination. They'd have the same hair length, fur length as their parents. And then some of them would get the long gene from mom and the long gene from dad and end up with a very long fur. And so you can see just in one generation, you can get a tremendous variety of dogs just in one generation. We're just looking at one trait too, hair length, and there are many other traits as well. So lots of variation. Is there any evolution here yet? Well, no. I mean, we started with dogs. We ended up with dogs. So there's no evolution. It's just dogs. It's variation within a kind. That's not surprising. Have we gained any new instructions, any new information? No. We started with information for long and short, and by implication medium, and we ended up with information for long and short, and by combination medium. The information was there in the beginning, it just wasn't expressed. At least the information for short wasn't expressed, or the information for long, but it was still there. They haven't gained any new information. Now, suppose the weather gets very, very cold outside, which would be nice this time of year in Texas, let me tell you. And so what's going to happen? Well, the dogs that have the shorter and medium length fur, they don't do so well in that cold climate, do they? No, they're very uncomfortable, and so sadly they die. I didn't say natural selection was nice, I just said it was true. Anyway. Now what happens is these dogs that have the longer fur, they go on and find other dogs that have survived because they have longer fur, right? And so they get married and reproduce. Now, the dogs that had the shorter and medium length fur, they don't reproduce because they're dead. Yeah. But the ones that have the longer fur, they do. And what will their pups look like? Think it through. They're going to have the long fur because that's the only combination left. They're going to get a long fur gene from mom. They're going to get a long fur gene from dad because that's the only combination that's left. And at that point, all the dogs will have long fur. And this is a wonderful example of adaptation. It's one type of adaptation. The weather got very cold, and lo and behold, the dogs that ended up surviving there had the longer fur. There are other ways that can happen, but that's certainly one way. Any evolution? No, we started with dogs, we ended up with dogs. No evolution there. Have we gained any new information? We started with information for long and short, and we ended up with what? Just information for long. We actually lost information. What happens if at this point a heat wave comes? Will the dogs go back to having the shorter fur? No, they're just going to die. That's it. Because they've lost the information for short fur. It's gone. And so you see, natural selection doesn't increase information. It reduces it every time. Now, if we started the experiment over and you had all three varieties, the long, short, and medium, and this time, let's suppose there's a heat wave. Okay? Now what's going to happen? Well, now the dogs that have the longer fur, they don't do so well in that heat, and so sadly they die. But the dogs that have the shorter fur, they do well in the warmer environment, and so they find other dogs that have survived in that warmer environment, they reproduce. And again, you end up with dogs. This time, you have dogs that survive are the ones that have the short fur because they're the only ones that can survive in that kind of climate. The other ones have died. Again, is there any evolution here? Not at all. We started out with dogs, ended up with dogs. We started out with information for short and long. We ended up with information for short. We reduced information. You see, natural selection is the opposite of evolution. It really is. It's in the wrong direction. You can't turn bacteria into horses by natural selection. You can't remove information and get new information somehow from that. But this does explain why we find animals that are well suited to their environment, or rather why we don't find animals that aren't well suited to their environment. We find that, lo and behold, the dogs that end up in the colder climates have the longer fur. If they didn't, they would have died. The dogs that end up in the hotter environments have the thinner fur. If they didn't, they would have died. And you still have quite a bit of variation with the dogs that are in sort of the intermediate climates. But you see, you don't need millions of dogs to account for the variety that we find in dogs today. You can start with 2. That's all you need on Noah's Ark. Noah would have needed 2 dogs. That's it. And from those dogs, after they get off the ark and they reproduce and breed and lots of dogs, and they end up dispersing from the mountains of Ararat, and they take certain traits with them. Some of them would be helpful in the environment they're in, some not so helpful. Some would be sort of neutral. It's just the traits that they ended up with. But that's how we account for the different varieties of wild dog that we find in the world today. Lo and behold, the ones in the colder climates have the thicker fur. The ones in the hotter environments have the thinner fur. If they didn't, they'd be dead, and they wouldn't be there. And so this is how we account for the different varieties of wild dogs. It's just the combination of information that God put in the original dog genome, the collection of all the genes, and natural selection working over time, and you end up with all these different varieties of dogs. Now, my natural selectionist, the folks who believe that natural selection, the folks who believe that natural selection somehow drives evolution would say, oh, but Dr. Lisle, it's not just natural selection. It's natural selection and mutations that drives evolution. So let's talk about mutations. A mutation basically is a typo in your DNA. Okay, it's a mistake, an error. So you have all these instructions in your DNA, and then one of them gets garbled for whatever reason. Sometimes in the process of getting copied, your DNA is always being copied, and you need that to, whenever you produce new cells or when you produce a new human being, you got to get that information there. So it's always being copied, and sometimes a typo occurs, a mistake happens. And so suppose you have dogs with genes for 4 normal legs. Now, all dogs should have that information. That's not variable. That's not one where there's 2 different versions. All dogs should have 4 normal legs, but there is a mutation that causes some instructions to be lost, or sometimes more than one mutation, and you end up with a dog with short, stubby little legs, okay? And if you think about it, that dog, because he's missing some instructions, his legs don't form quite properly, and so he's close to the ground. And if you think about it, that dog would not do very well in the wild, would it? Because he can't run very fast with those short little legs. He can't catch anything. He's more likely to get picked off by something himself because he can't really run very well. And so a dog like that's not going to do very well in the wild. But some people like dogs with short, stubby little legs, right? Because they can't jump up on you as much. And so people will take these, say, oh, don't worry, I'll take care of this little creature. And this dog doesn't have to survive in the wild because he has a human caretaker who will feed him and take care of him and provide for his medical needs. And then people who like the kind of dogs say, well, hey, let's breed these together, and you end up with lots of dogs with short, stubby little legs. They don't have to survive in the wild because they have a human caretaker. And so we've kind of alleviated natural selection there. We have artificial selection instead. And that's why domestic breeds of dogs are full of mutations. So some of them, they'd never make it in the wild. All kinds of different mutations. There's a mutation that causes a dog's snout not to form properly. A dog's supposed to have a long snout. That helps with the olfactory sense and so on. But there's a mutation that causes the snout to be short. The skin, however, was designed to fit the longer snout. So the skin hangs off the side. And some people think that's cute, but you ever think about it from the dog's perspective? Gee, I love having my nose stuffed into my face. That's great. Well, maybe not. Well, in any case, from the dog's point of view, probably not so great. Poodles. And I'm not anti-poodle, but they really do have some problems because they have mutations, lots of mutations. And as a result of those mutations or secondary effects, they tend to be very disease prone because they're a purebred dog. You see, they've got those mutations concentrated in them. There's a mutation, for example, in a poodle's hair grows forever. A dog's hair is supposed to grow so long and then it falls out, and that regulates the hair growth. With a poodle, that gene is damaged, and so the hair grows indefinitely. And there's no way it could survive in the wild. It'd be trying to drag all that hair behind it. It's not going to work. And so human beings have to go and give it a haircut every now and then, which is why you see all the strangest haircuts on poodles, because you have to cut their hair. In fact, if you don't do that frequently, the hair can get in their ears and they can get infected and they go deaf and get in their eyes and then go blind. Some of these mutations are even lethal. And so a friend of mine says you spend millions of dollars trying to keep the poor thing alive because it's missing all these instructions that God put in the dog kind originally but have been lost over time due to mutations. And so now is this evolution? Well, not at all. Not at all. I mean, we started with dogs. We ended up with a dog, sort of. But we haven't added any brand new instructions, right? Mutations really just remove instructions even faster than natural selection does, because it removes instructions that in a perfect world would never have been removed. Okay, in a perfect world, a dog would regulate its own hair growth. And so it's actually removing information at an even faster rate than natural selection would by itself. But it's not adding brand new instructions. Mutations don't do that. They remove information. And that's why you end up with some of the varieties of dogs we have today. It's a combination of the original information that God put in the dog kind and mutations, little mistakes that have crept in. And that's how you account for the different breeds of domestic dogs. It's just people take the little mistakes that they like, and they encourage those dogs to breed with each other. And so you can end up with all kinds of varieties of domestic breeds of dog. But it's not evolution because it's in the opposite direction of evolution. We think the dogs that would have been on Noah's Ark would have been closest to the wolf in terms of dogs that are still alive today. In the wolf, you have a lot more of the heterozygous genes, big A, big B, little b, and so there's potential for variation. But what happens is, over time, as you inbreed these dogs and you remove the number of variations, you get down to something like a poodle, but you haven't added any new instructions. You've actually lost instructions. This process of the dogs that came off Noah's Ark reproducing and getting all the way down to something like a poodle, that's an information reduction process. You're removing instructions. And so it's in the opposite direction of evolution. When I'm explaining this to youngsters, a lot of times I'll say it's like jelly beans. You can think of the information in your DNA like jelly beans. And so you got the wolf kind, lots of jelly beans, and then you go down to the coyote and the dingo and the collie and so on. As you concentrate the mutations and you remove more and more information, you get down to the poodle, and then you have some problems on your hands because they don't have that much information left. A little bit exaggerated here, but you get the point. Now, could you ever turn a dog into a cat by this process of removing jelly beans? No, because a cat has different information, and so we represented it that way there. You can't get different information by removing information. So you see natural selection and mutations, they could never turn one kind of organism into another. It's not possible, because in both cases, natural selection removes information, mutations remove information. And that's not what you need to change one kind to another. You need to add information. You need the exact opposite of mutations and natural selection. So you see when we examine genetics and we see how dogs reproduce, we find they reproduce dogs. And that's what we'd expect in the creation worldview. Now, this is all good observational science. It's something we can test in the present, right? It's something that's testable, repeatable. You can do all kinds of experiments breeding dogs. You will always get dogs every single time. And that's what we'd expect from Scripture. So you see, observational science confirms what the Bible teaches. It does not confirm what we'd expect if evolution were true. And they've tried these kinds of experiments on bacteria as well. Bacteria can reproduce, I forget how many times a day, but it's ridiculous. I mean, they reproduce constantly. And, the scientists, they'll, breed them and then wipe 99% of them out and then let them repopulate and wipe them out. They're still bacteria. And they've had the equivalent of millions of years worth of what it would be for something like a dog to reproduce, and they're still virtually identical to their ancestors. Now, again, you can have variation within a kind, but they're still the same basic kind. I should point out that mutations can be beneficial. There are mutations that can help an organism survive under certain circumstances, but they still don't help evolution because they're still in the opposite direction. They're loss mutations. I'll just give you one example of this, antibiotic resistance. And again, this is something where some of the evolutionists will say, see, here's evolution in action. These bacteria have become resistant to penicillin. Or you've heard of those, superbugs. Well, when you really examine the story, it's the opposite of evolution. And here's one way that this happens. All of them involve a loss, however. H. pylori was a bacterium that causes stomach ulcers. And so what happens is you can take an antibiotic to kill this organism because the antibiotic is not in itself poisonous to you, but when it penetrates into the bacteria and he absorbs that, he's got an enzyme that's part of his natural chemical makeup that reacts with that antibiotic and turns it into a poison, and then the poison kills the bacterium and you feel better, okay? That's the way it normally works. There is, however, a mutated form of H. pylori who is missing the gene that produces this enzyme that reacts with the antibiotic. He lacks the ability to produce that enzyme that would normally react with the antibiotic and kill him. And so he actually survives. But not because he has more information in his DNA, but actually because he has less. He's missing some instructions, and in this case, when you give him a nuclear dose of antibiotics, it doesn't harm him, or at least not as much, because he doesn't have that enzyme. In fact, he has a little bit, but not very much. And so eventually the antibiotic would kill him as well. But what happened, by the way, that's why you need to take all of your antibiotic, right? Because you start to feel better because you've killed 99% of the bacteria, but the ones you haven't killed are these ones that have this mutation. So you have to take it a little bit longer to get rid of all of them. Otherwise, the group that grows back will all have that mutation. It'll be harder to kill. You get the idea. My point here is that the healthy, the normal bacteria, the healthy ones, they're killed by the antibiotic because they have instructions in their DNA. The ones that are missing those instructions actually survive, but they survive because of less information. And so in all cases that we know of where the mutations have been studied, they always reduce information in the genome. Even the ones that help an organism survive, and even those ones are kind of rare, but they happen. Dr. Lee Spetner, PhD in biophysics from Johns Hopkins University, says all point mutations that have been studied on a molecular level turn out to reduce the genetic information, not to increase it. He goes on to say, not even one mutation has been observed that adds a little information to the genome. And he's been studying those mutations for decades. And they're always in the wrong direction to make evolution happen. Isn't that interesting? So again, when we study genetics, we study mutations, natural selection, and we apply good observational science, we find it's very consistent with what we'd expect from God's Word. Because God is the one that created that original information in the organisms. And some of that's been lost since creation, but we haven't gained any new instructions Certainly you can't do that by mutations in natural selection. And the kinds we see today are the same kinds that we had at creation. Some of them have gone extinct. But you see different varieties, variation within a kind, exactly what we'd expect based on Scripture. Well, I've been talking a lot about information, but what is information? That's one of those kind of abstract concepts like math that's a little hard to wrap your brain around sometimes. But we sort of have a feel for it. I mean, if you pick up a book and and I pick up, it doesn't have to be a Bible, any book, you can pick it up, and I get this one upside down, there we go. Pick it up and you see, okay, and here we see the word servant, okay? What is, okay, there's information there, right? Well, information, we can define it in terms of these three characteristics, and there are more than this, but this is, I'm watering it down just a little bit. There's a symbolic code system. So when I see the word servant here, I don't actually see a servant here. I see a word which represents an idea that I understand. And so, a picture forms in my mind. Okay, what a servant is, I know that. So it's symbolic, it's encoded. There's a language convention. Now, this Bible happens to be English. The Bible was originally written in Hebrew and Greek and some Aramaic, but I can't read those, so I read an English version. But in any case, there's a language convention there. And there's meaning. There's an expected action and an intended purpose. And so God had a reason for writing this. And in any book that's written, there's a reason why the person wrote it, and there's something that they're expecting you to do as a result of that book. And in some cases, it's just to become educated on the topic, but in other cases, it's a very specific external action. In a cookbook, for example, you won't see a cake in a cookbook. You'll see instructions. You'll have that symbolic code system. There'll be a language there. And there will be, the expected action is that you'll bake the cake, that you'll put the ingredients in that end. And the purpose is that you'll have something to eat. And so you see that follows all of the necessary principles of information, as does the Bible, as does any book that has good creative information in it. And so let's try one here. How could this be information? So we have a series of looks like little icons there. Could be information, right? Because it looks like that could be a code system of some kind. It's possible. There could be a language convention there. It looks organized, and so there could be a language convention there. It might have an expected action and an intended purpose. It could be meaningful. And in fact, I'll just tell you this is information, and the reason I know it's information is because I know how to translate it. And I'll show you. It turns out this is Genesis 1:1-5. You see, in the beginning, the clipboard, right? God created the heaven and the earth was without form and empty, and darkness was over the waters, and the Spirit of God was over the face of the deep, and the Spirit of God was hovering over the waters. And God said, "Let there be light," and there was light. And God saw the light that it was good. I like the good symbol. See that? It's information, isn't it? Because you've got a symbolic code there. It's different from the way we're normally used to reading, but it's a symbolic code. It works. You can decipher it. That's the easiest way to tell that there is definitely information there. In fact, it's probably the only way you can know for sure that it's there is if you can decipher it, if you can translate it, and you know what it represents. Things like repeating patterns don't have information because there's no instructions there. Now, whenever you have information, certain rules apply. There are certain laws of nature that deal with information, just as there are laws of nature that deal with energy. There's the law of conservation of energy, which says you can't create energy or destroy it. So the amount of energy in an isolated system is constant. And that's a law of energy. And so if somebody says, well, no, I've created brand new energy, I can immediately say, no, you're mistaken, because there is a law of nature that prevents that. And we've observed that over and over again. Likewise, there are laws of nature that pertain to information. And one of these laws is that information never spontaneously generates in matter. And Dr. Werner Gitt, one of the world's experts on information theory, says there is no known law of nature, no known process, and no known sequence of events which can cause information to originate by itself in matter. So the idea of information just kind of spontaneously generating, he says, not possible. There appears to be a law of nature against that. So where does information come from then? If it doesn't just spontaneously generate in matter, where does it come from? And it's sort of intuitively, I think we know the answer to this. It comes from a mind. Any book that you read, if it's got creative information in it, you probably figure somebody wrote it. I mean, that's pretty likely, isn't it? You don't think it was probably produced by an explosion in a typewriter. If there's creative information there, somebody wrote it. That makes sense. It goes back to a mind. And that, in fact, is a law of information theory. Dr. Gitt says, when its progress along the chain of transmission events is traced backwards, every piece of information leads to a mental source, the mind of the sender. So he's talking about a copying process. If I pick up a book and I say, where did the information in this come from? It probably has been copied many times. It was probably copied from, maybe a Xerox machine, and maybe that got its information from another book, and that got its information from a computer, which was copied from another computer and another one. But if you trace it backwards, eventually it'll go to a mind, the mind of the sender. Ultimately, somebody with intelligence wrote that book or article or what have you. If it's got information in it, that has to be the case. And that's common sense, isn't it? And yet, when we look in DNA, we see information. A lot of information. In your DNA are 3 billion base pairs. That's the instructions that it takes to make you. And they're encoded in such a marvelous way. I mean, it's absolutely ingenious the way that God encoded our DNA, because there are promoter segments where it'll either read this one, or it'll read this, or it'll skip this section and read another one. So you can get multiple proteins from a single strand of DNA. It's phenomenal. We've learned that some places in the DNA even can be read in reverse, and you get a different protein. That's phenomenal. To give you an idea for what that means, it'd be kind of like if you read a book and it made sense, and then you picked it up, turned it upside down and backwards, and read it the other way, and you got another story that also made sense. No human being could write a book like that, but your DNA does that. Maybe not all of it, but at least some of it. It's astonishing. I can't even comprehend the kind of intelligence it would take to do that. I mean, some people are good at coming up with palindromes, words that make sense the same way forwards and backwards. 10 animals I slam in a net. And you read it backwards, and it's the same thing. It's kind of like that. It's hard to come up with those, though. You have to be clever. I didn't come up with that, but I just repeated it. But it's astonishing. Now, where did the information in our DNA come from? It's been copied many times. You got it from your parents, right? They got it from their parents. They got it from their parents, and so on. Ultimately, all the way back to Adam and Eve, and they got it from God. The information in your DNA ultimately comes from God. It comes from a mind. So you see, creation is consistent with information theory. Evolution is not. Because in the evolutionary view, the idea is the information in your DNA gradually accumulated over millions of years of natural selection and mutations. But there's a law of information theory that says that doesn't happen. Information always goes back to a mind. It can't accumulate spontaneously in matter. We've never seen any exceptions to that. I mean, it's interesting to me that, of course, you pick up a book, of course it has an author. But then you read this book, which is DNA, that's just random chance. You see, it's very inconsistent. And, I know that in their heart of hearts, evolutionists really do understand that information comes from a mind. In their heart of hearts, they really do know that. And I did a little social experiment to prove this a few years ago. I posted an article called On the Origin of Articles. And you can check this out on my blog. It's just jasonlisle.com. But the article here is designed to convince you that articles do not have authors, that articles are in fact generated by typos that gradually make the article longer and better. And of course, most typos make the article worse, but those ones are rejected. And so the few that make the article better and longer and gradually, that's how all articles have evolved from probably from a common letter over millions of years of natural processes. There's no author involved. And the funny thing was not so much the article, but the responses to it. Because I allow evolutionists to chime in and comment on my blog, and they chimed in and said, "We know you wrote this, Dr. Lisle." I said, "How? Did you see me writing it? What is your evidence?" "Well, we could trace back your IP address or whatever." I said, "I already admitted to posting it. I didn't say I didn't post it." I said, "How do you know I wrote it?" I said, "When this appeared on my computer, I just had to post it." I mean, it was just that amazing. I wanted to share with the world how articles really have evolved over millions of years. Well, we know you did. They couldn't give me an answer, could they? I said, "No." I said, "I think you're wrong. I think articles come about by chance. In fact, if there is an author to this article, let him show himself to me right now, and then I'll believe." I mean, if you want to believe that articles have authors, that's fine, but keep it in church, man. It was fun for me to take on the role of the evolutionist and kind of have fun with these guys a little bit. And they couldn't answer it. They were stymied because the only response they could possibly give that would make any sense is, well, it's got information in it, so of course it has an author. But as soon as they say that, evolution's out. Because in your DNA, you got information. If it is unreasonable to suppose that articles come about by chance, how much more unreasonable to think that life came about by chance, which is far more complex. This is only, what, a 1,500-word article. You got 3 billion letters in your DNA. SETI, the search for extraterrestrial intelligence. You've heard of this program. They have these radio dishes pointed in space, listening for alien signals. Well, there's lots of radio transmissions in space. The sun gives off radio. Did you know that? It sounds like static, but I've listened to it. It's kind of interesting. And other stars, there are objects called pulsars that give off these little blips, bip, 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 like that when you listen to them in radio. So there are lots of natural radio sources. But they want to find alien life, right? They want to find alien intelligence. So how would you distinguish an intelligence signal from all these random natural signals? And the answer, of course, is, well, the intelligence signal from actual aliens would have information in it, right? That's how they distinguish it. So you see, my point is, even the most ardent secularists in their heart of hearts, they know that information requires a mind. If we got instructions from space on how to build a warp drive and we built it and it worked, we'd say, wow, there's got to be intelligence out there. I'd be convinced of that. I don't think it's going to happen, but that would convince me, okay? But you have them point the microscope right in the other direction. You got DNA. Oh, that's just chance. Very inconsistent. It shows that in their heart of hearts, secularists really do believe in God, the God of biblical creation. Let's talk about geology now, rocks and fossils, and that sort of thing, because this is another area where they said, well, you can't trust the Bible because, well, first of all, we know the world is billions of years old, whereas the Bible says God created in 6 days, and apparently there was a few thousand years ago from those genealogies. People have the impression that radiometric dating proves the world's billions of years old. And radiometric dating, I'm going to go through this in some detail because I think it's good for us to understand how this works, how it's supposed to work anyway. Because people have misconceptions about it. They think it's all just, the rock is there and you just point your tricorder at it and scan it and it tells you how old it is, you measure the age of it. Well, you can't measure age. Age is not a substance that can be measured with a tricorder or anything else. It's not like it's like rocks have agicles in them and you measure the amount of agicles, no. The way it works is of course, rocks are made of, everything's made of atoms in terms of everything material. And rocks are made of, a certain fraction of them are radioactive atoms. Radioactive atoms are unstable, which means that they will spontaneously change into another type of atom. And people make fun of people of old for believing in alchemy, but that kind of happens in a way, right? Certain atoms will spontaneously change into other atoms. It's just not, gold is not one of them, but unfortunately. But anyway, uranium-238, for example, is one of these radioactive atoms. It will spontaneously decay into thorium, which spontaneously decays in the next one, which spontaneously decays and so on. And you don't have to touch it or do anything. It'll do it on its own. And it's a slow process. It happens because atom by atom. And in fact, for any individual atom, you can't make any predictions about when it's going to pop off. It just does it. But statistically, if you have a group of them, you can predict very precisely how the substance will change from uranium all the way into lead-206. Lead-206 is stable. So once you're lead-206, you're always lead-206. Unfortunately, most of the atoms you're made of are stable, so you're not going to spontaneously change into something else in the next 24 hours anyway. But uranium is not like that. Uranium is unstable and changes to lead. And so the bottom line is if you had a chunk of solid uranium, after a while it would be part uranium, part lead, and part those intermediate elements too, which we haven't indicated just for simplicity. And then eventually it would be all lead. Uranium does change to lead. And they measure that by what's called a half-life, and the half-life is how long it would take for half of it to decay, and it's very long for uranium, because we know by measuring it over a short period of time that just a little bit of uranium changes to lead, and so we can extrapolate. And we know that if it were, basically it would take a long time. It would take billions of years for uranium to change into lead, all things being equal, but all things are not always equal. The idea then is you can use that like a clock. If you have a rock that has some uranium and some lead in it, you can use that, knowing the rate at which uranium changes into lead, to figure out when the rock was created, when it was all uranium. But how do you know it was all uranium to begin with? That's one of the issues, right? And by the way, secularists don't assume that the rocks were all uranium to begin with. They assume there was some lead in them to begin with. And that affects the age estimate, right? I mean, if you assume it was all uranium and it takes 4.5 billion years for it to decay to this amount, But maybe I made it yesterday in the laboratory and it already had that ratio of uranium to lead. How do you know? How much uranium should we start with? Well, you tell me how old you want the rock to be, I'll tell you how much uranium to start with, you see. You can think of uranium changing to lead like sand going from the upper chamber to the bottom chamber in an hourglass. You can use that to tell time if you make certain assumptions. If I came into the room here and there was an hourglass, maybe when you all came in, I had an hourglass here, and it looks just like that, about halfway done, and it's an hourglass. And so I ask you, how long did I turn that over? And you say, that's easy, half an hour. I say, gotcha. I turned it over 1 minute before you came in, but already a lot of the sand was in the bottom chamber. You see, you can't assume that all the sand was in the top chamber. You can't assume that the rock was all uranium to begin with, and evolutionists don't. Or they get an age much older than the age that they want for the Earth. Or how do you know that somebody didn't add sand when you weren't looking? Probably not too realistic for an hourglass, but uranium is leachable in salt water. It can move in and out of the rocks. Kind of interesting. And so it's not a closed system even. Or how do you know that the throat of the bottle has always been the same size? Maybe it fell through more quickly in the past. That's probably a pretty safe assumption for an hourglass, a physical hourglass. But in terms of the rate at which radioactive decay happens, we don't exactly know all the details of how that works. And so it's a possibility that it could have decayed more quickly in the past or under different circumstances. And that turns out to be a real killer because we now know that it is possible to speed up radioactive decay under certain circumstances. When I was in school, they said, the reason why we use this as a clock is it's totally unaffected by chemistry or anything else. It ticks at a constant rate. Well, we now know that's false. In fact, scientists have been able to speed up certain kinds of radioactive decay in a laboratory by a factor of 1 billion. I think it's the rhenium-osmium reaction. You can speed it up by a factor of 1 billion in a laboratory just by stripping away the electrons from the atom. Really fascinating. So here's my point. All of these age dating methods rely on assumptions about the past that you ultimately can't really know. How do you know what the initial amount of uranium to lead is in the rock? And there are some clever mathematical tricks they use to try and make a guess at that, but it's still a guess, ultimately. How do you know the system is closed? And the killer, number two, that the decay rate's constant. There was a project we did in ICR some time ago called the RATE Research Project, and we found very compelling evidence that in the past, the decay rates of these elements were much faster than they were today, perhaps during the creation week or during the flood year or both. And I won't go into details on that. If you want to read about it, we do have it on our website. But there's very compelling evidence that this assumption is wrong. So it's all based on assumptions. And here's the bottom line. We know that radiometric dating doesn't work. Why? Because we've tested it on rocks of known age, and it gives the wrong answer. We've taken rocks, for example, from Mount St. Helens, and brand new rocks, and the radiometric age is supposed to tell you when the rock hardened, because then the minerals can't move in and out. That seals it. So we took brand new rocks from Mount St. Helens, which erupted in 1980, and there were a few subsequent eruptions. Rocks that had just hardened, sent them in and had them dated in a secular lab so we couldn't be accused of bias. And they came back with ages of hundreds of thousands to millions of years on rocks that we know the true age is close to zero, right? It's just a few years old. And it's kind of an interesting experiment because normally they wouldn't bother to test a rock of known age. It's expensive to radiometrically date a rock, but we wanted to test the method. And so we sent them rocks that we know the age for it, and they got the wrong answer. And you say, well, that's just the exception. Actually, that's the rule. Sometimes you get the right answer, but often you get an age that's much, much older. Very consistently, like in Hawaii, if you take rocks from Hawaii and date them, you will get millions of years. Even if they're you saw it come out of the volcano. Pick it up on a stick and take it in, date it, you'll get millions of years, even though it's brand new, very consistently. I've been trying to talk my boss into making a trip to Hawaii to do this experiment. He hasn't gone for it. Sometimes you can even get a negative age. That's kind of interesting. Certain radiometric dating techniques allow you to get an answer that's negative. You can hold in your hand a rock that, according to radiometric dating, has not formed yet, which is interesting. Those tend not to get published, but you can imagine why. What about carbon dating? Carbon dating is actually better because at least when we test it, and it's not infallible either, it's also based on assumptions. But the nice thing about carbon dating is when we test it on things of known age, it tends to give the right answer up to at least a few thousand years, and then it gets a little bit older than it should be, but it never gives millions or billions of years. Carbon dating is our friend. Carbon dating tends to give the right answer, and it's consistent with the biblical timescale. Same type of thing. You got certain atoms that are unstable, C14, Carbon-14. Most carbon is carbon-12. 12 is good, the 6 protons and 6 neutrons, but there's a variety of it. C14 that has 2 extra neutrons in the nucleus, and that makes it unstable. It will spontaneously decay into nitrogen with a half-life of 5,700 years. So it's actually a faster decay rate than uranium. And the C14 is produced in the upper atmosphere when cosmic rays strike nitrogen, convert them into C14. And so everything in nature, plants and things, they take in that air, right? They take in carbon dioxide, and that becomes part of the plant, and the carbon becomes part of the plant. And then you eat the plants, and so you've all got a little C14 in you. So you're all just a little bit unstable. How about that? You knew that. Now, when you're alive, of course, what's happening to that C14 in you? It's decaying. It's turning into nitrogen, a little bit at a time. But when you're alive, you're eating new food. You're taking in new C14, and so it gets replenished. And you're breathing, and so you're exchanging substances with your environment. And so while you're alive, the C14 to C12 ratio in you is about the same as it is in the environment. But when you die, you no longer eat food, you no longer breathe, and so you no longer are taking in new C14. The C14 simply decays away. And so the idea is, by measuring the C14 to C12 ratio in something that is dead, that has carbon in it, you can tell how long ago it died. And you tend to get the right answer. And you never get millions or billions of years. Did you know you can date dinosaur fossils if they have enough carbon left in them, if they have collagen left in them? You can date them. We've done this. We've sent them to secular labs. We didn't tell them they were dinosaur fossils, that we just said we want these dated. And they came back with ages of thousands of years, not millions or billions. Isn't that interesting? In fact, we have no counterexamples at the moment. There are none that have come back with no measurable C14 in them, which would be what you'd expect if they were millions of years old. We've found C14 in diamonds that evolutionists believe to be 1 to 2 billion years old. But if they were even 1 million years old, there would be no C14 left in them. And we find C14 in them. We find it in everything in fossil record. It's kind of amazing if it has carbon in it. There are hundreds of processes like that indicate that the world's much younger than what the evolutionists teach. The rate at which salt fills the ocean, all the rivers in the world, even fresh water has a little bit of salt in it, picks it up from the continents, dumps it into the ocean. The water evaporates, leaves the salt. You can get rid of a little bit of the salt with salt sprays and things like that. But for the most part, the oceans are getting saltier, a little bit saltier every year. And we can measure that rate, at least approximately. And you do the math, and you find that the oceans can't possibly be older than 62 million years, even being generous to the critics. And that's not the true age of the ocean. That's an upper limit, right? Because you can't have less salt than no salt. So that would assume 62 million years would assume that the oceans had no salt in them to begin with. But in fact, they probably had a lot of salt in them to begin with. So the true age is much less. But my point is, the maximum age has to be less than 62 million years, which is consistent with creation, but it's wildly inconsistent with the secular notion of the oceans being 3 billion years old, or the rate at which mud accumulates on the ocean floor. The rate at which it accumulates, about 20 billion tons per year. You can get rid of a little bit of that with subduction, plate tectonics. But as far as we know, the other 19 billion tons simply accumulate. You measure the amount that's there. You don't get anywhere near billions of years. It takes less than 12 million years to accumulate the current amount of mud on the ocean floor, and that assumes no worldwide flood, which would dump a lot of mud very quickly. So the true age is much less than that. It's consistent with creation, wildly inconsistent with the deep time folks. Human population, how long does it take to get Earth's current population of human beings? According to evolutionists, human beings go back, 1 million years or so, something like that, out of Africa. You don't get anywhere close to that, though. If you do the math, the population growth rate is astonishing. It only takes a few thousand years to get Earth's current population. It's very consistent with the flood, because remember, people had to start over with the flood. You had to start over with 8 people again. But the best reason to believe in a young world is because it's what the Bible teaches. And this really is the only one that's foolproof, because all scientific or pseudoscientific ways of trying to make a guess about the past, they all are based on assumptions. You can't get around that, because we don't know what the rate of things was in the past and how things started. But here we have the birth certificate of the universe. And that's really the only way you can know for sure how old something is to check its birth certificate. So the secular scientists say the Earth is billions of years old, take my word for it. God says I created in 6 days, take my word for it. And we've seen lots of evidence that confirms what God has said in his word and is wildly inconsistent with evolutionary notions. I could talk about that for millions of years. So let's move on. Let's move on to fossils themselves. Fossils, I was always given the impression that fossils sort of took a long time to form. They formed over millions of years, allegedly. Well, here we have a fossil ichthyosaur. killed, buried, fossilized in the process of giving birth. You see the baby ichthyosaur being born there? They're born tail first. These are marine reptiles. They're thought to be extinct today. But because they're air breathing, they're born tail first, so that as soon as he's out, he can swim to the surface and get his first breath of air, which is kind of interesting, kind of neat. Here you have a fish fossilized in the process of eating another fish. I don't think that took millions of years to happen. Obviously, whatever happened here happened quickly. It buried them, it killed them and buried them fast. And apparently they fossilized before all of it could decay away. Most of the flesh is decayed, the bones are still there, but you can even see some of the stomach contents there. So it's, you see, people get this idea of fossilization. You die and then you slowly fossilize over millions of years. Normally you don't fossilize at all. And we're going to do a little thought experiment here. I've been picking on dogs, so let's pick on cats now. So we're going to do an experiment on our dead cat, Earl, and watch him slowly fossilize over millions of years, allegedly. Okay, so scientific experiment progress, do not touch. Day 1, dead cat on grass. Okay, day 3, what happens? Smelly dead cat on grass. Yeah. Okay, well, maybe he's starting to fossilize. Let's wait a little longer. Okay, very smelly dead cat on grass. Yeah, this is not going well. You can see why we use cartoons for these and not actual images. Day 20, part of Earl missing. Yeah. Day 38, more of Earl missing. And then day 65, Earl's missing. And so, and you know this. You're laughing because you know that this is what happens. It doesn't just slowly fossilize over millions of years. You've seen animals that have been killed and left on the side of the road. They don't last very long. They decay very quickly. They decay and they're recycled back into the environment. Most things don't fossilize at all. They're recycled. If you want to fossilize something, you got to bury it. And even then, I was given the wrong impression. We find fossil fish all over the world, and I was told, yep, those are buried in rock layers that were laid down over millions, hundreds of millions of years. And so the fish dies, it sinks down to the bottom, and then a million years later, another layer comes and partly covers it, and then a million years after that, another layer comes and covers it a little bit more, and then another million years after that, it's all covered, and later you dig it up and find the fossil. But it doesn't make any sense, because if it took millions of years for this to deposit, why hasn't the top of the fish decayed? Right? In order to fossilize something, you got to bury it quickly. And generally fish, they tend to float when they die, actually. And if you've ever seen those specials where they show you the bottom of the ocean, I love those kinds of specials. Even sometimes they get into evolutionary stuff, but when you see the ocean floor, do you see just billions of dead fish waiting to fossilize? That's not what you see, is it? It's very active, and there's scavengers that are going around and so on. So no, that's not the way to form a fossil fish. Now, if you really want to form a fossil fish, here's how you do it. You go home to your aquarium, and okay, you're going to fossilize the fish there. He's happy because he doesn't know what's about to happen, and you pour some concrete on him like that. Okay, it's going to kill him. It's going to bury him very quickly. And generally, there's enough bacteria left that even the soft parts can decay away, but the bones will mineralize. And so you can actually make a fossil fish that way. See, rapid burial is what you need to form a fossil. And let's see, is there an event in history that would form lots of fossils very quickly, that would bury them in rock layers laid down by water all over the world? The worldwide flood would do that, wouldn't it? You see, it's exactly what we'd expect. We'd expect to find fossils all over Earth if there's a worldwide flood, and that's exactly what we do find. And by the way, you find fossils of marine organisms mixed with land organisms. We have one of the fossils we have on our wall outside ICR there, or in one of the office buildings. I love it. It's a fossil dinosaur and a fish. Now think about that. It's one of the smaller dinosaurs, buried right in the same layer with the fish. Now, where did they live? That's what I want to know. I mean, was he visiting his friend there at the bottom of the ocean, or did the fish come up? And obviously, it was a flood that did that. It's very, very clear. And that's not the exception. That's the rule. You tend to find these things mixed. What about the kinds of fossils we find? Do we find evidence of one kind changing into another? Well, no. And the best you can find even in the evolutionist textbooks, you'll find things like that. You say, well, see, there's the evolution of the horse. There you go. And I'm thinking, I see horses. To me, that looks like variation within kind. Doesn't it look like that to you? I mean, you see, but the feet are a little different. But, well, that's okay. I mean, they have little differences in their feet. That's a very minor difference. And their rib cage, well, they have different numbers of ribs. Well, okay, that can happen. By the way, the number of ribs doesn't go in the same order as size. So you got to decide if you want to go by rib number or size. So there's some inconsistencies there. And of course, Well, look at the stripes that he's gaining. He said, well, of course, you don't know anything about that, right? All you find are the bones of these creatures. You don't know what they looked like on the surface. And even this one right here, you see, that looks like it could be a proto-horse. Well, that's actually a type of badger. It's a rock badger. But when they gave it to the artist to draw it, they said, they give the skeleton, we think this was the proto-horse. And so that's what you end up with there. There's a difference between evidence and artwork. This is artwork. Anyway, these people say, but they're different. They're very different sizes. But you have horses of different sizes today. These are both adult horses. They're just different breeds. And so, there's lots of variation within the horse kind. And apparently some of the variations have gone extinct that had slight differences in the way the feet, instead of the single hoof where they split out and so on. It's exactly what we would find given creation. But you don't find evidence of a non-horse changing into a horse. You don't find that. And I remember, I think it was a camel they were showing, the evolution of the camel, and you saw a variety of camels. Where's the evolution there? Variation within a kind is what you find. What about the rock layers in which these fossils are found? I was always given the impression that the rocks at least took a long time to form, right? Because mud slowly turns into rock over millions of years. Well, here's a set of car keys embedded inside solid rock. I don't think that took millions of years to form, unless cars were around a lot earlier than they think they were. Here's a man-made clock embedded inside solid rock. How about that? I mean, I guess we know when that one formed, but that's, we know what time it formed anyway. That's about it. Isn't that fascinating? It doesn't take millions of years for rock to form. It just takes the right conditions. It takes the right chemistry. And what about all these rock layers, sedimentary rock layers that you find there? There's a person down there for scale. You say, well, surely those took, there's lots of them. That's got to take millions of years to build up those layers. Well, I got news for you. Those did not exist before 1980. Those were produced in the Mount St. Helens eruption. Actually, more than one eruption. You can see the top layers are a different eruption. But all those rock layers were not there before 1980. That was open space. And then the same volcanoes that created those rock layers also cut through them as well. So that was the result of the Mount St. Helens eruption, which was a pretty piddly volcano by volcano standards. And it cut out a canyon in those rock layers about 1/40th the scale of the Grand Canyon in a matter of days, maybe hours. Didn't take millions of years. The kinds of rock layers that we find there have these real fine laminations in them. You can see those real fine, real thin layers. You find those in the Tepete sandstone in the Grand Canyon. And they used to say, well, that's 1 year after the next. Those are annual layers. One of those is deposited 1 year after the next. You add them up, millions of years. Except that's not from the Grand Canyon. That's from the Mount St. Helens eruption. Those are all laid down in the same day. So that's just the way because of the way the mud flows, you get those layers. They're not annual at all. And those are the same kinds of layers that are found in the Tepete sandstone that covers most of the United States and Canada. These rock layers are continuous, by the way. Whatever laid down these rocks, laid down these rocks and these rocks and these rocks and these rocks. Deposition on a continent level scale. And that's consistent with what we find. Actually, one of our geologists at the Institute for Creation Research, Tim Clary, he's actually studying megasequences on the different continents on the Earth. And he finds amazingly compelling evidence of continent scale deposition, where it's a worldwide flood. It's exactly what we'd expect. We find trees buried vertically without roots. That's kind of interesting. How do you do that? They used to say, well, see, these were forests, and over millions of years they were, covered up and so on. But they don't have roots. That's the problem. Most trees I know of have roots, right? We know how this happens now, and it takes catastrophic conditions, because actually Mount St. Helens demonstrated this. Mount St. Helens, because when it blew, it uprooted a bunch of trees. That's why they don't have roots. And they tended to float in nearby Spirit Lake, and most of them floated vertically because the little bit that's left of the roots would get waterlogged, and then eventually they'd sink down to the bottom, and it produced exactly what we see in all these other rock layers. And it takes catastrophic conditions to rip up trees like that. It doesn't take millions of years. So all of this to say that when we take a look at these rock layers and the fossils within them, and we apply the kinds of science that we can see today, at least things like Mount St. Helens, this is good observational, repeatable science in the present, we find it's very consistent with what we'd expect given creation and a worldwide flood. It's wildly inconsistent with what you'd expect given a millions of years point of view. And really those fossils are a reminder that God judges sin. That was the whole point of the worldwide flood. It was because the wickedness of mankind was great. And God is a righteous God, and he won't tolerate sin forever. He's a merciful God. He gives us a chance to repent. But that's what the flood is all about. The fossils are not saying millions of years of evolution. What they're really saying is repent. That's really what they mean. Well, keep that in mind the next time you see a cut through one of these hills where they put the road and they cut through the hill and you see these layers. And those are flood layers, and you can find all kinds of dead organisms in them, a result of our sin, ultimately. And it's interesting. God is a just God. He will punish sin. He's done it in the past by water. He's going to do it again by fire. Are you ready? That's really the question we need to ask ourselves. But God's merciful, too, and he provided a way of escape. And in Noah's time, that was the ark. And that, I think, in a way, that symbolized Christ. Christ is really the only way we can escape the actual permanent effects of sin. We're all going to die. We're all going to experience that temporal judgment. But those of us who have repented of Christ, who have repented and turned our life over to Christ, will not experience eternal judgment because he paid our penalty for us. It's interesting, though. The Bible indicates that in the last days, scoffers would come and they would deny the worldwide flood, among other things. It says, for this they willfully forget that by the word of God the heavens were of old and the earth standing out of water and in the water, by which the world that then existed perished, being flooded with water. That's exactly what we're seeing today, people denying a worldwide flood. The Bible is exactly right. It's interesting. In their denial of the worldwide flood, they confirm what the Bible teaches they would say. They demonstrate its trustworthiness. It's because of what Adam did. We need a Savior. Because we're descended from Adam. We're sinners, and we deserve the same judgment of those that are buried in those rock layers in the flood. We deserve that same judgment. But God is merciful, and he provided a way of escape. But that grace period doesn't last forever, does it? I think it's very significant. The Bible says that God was the one that closed the door on the ark. God was the one that decided time of mercy over time of judgment begin. And we don't know when that is for each one of us. So that's why I encourage everyone, if you haven't trusted in Christ as your Savior, you need to do that. The Bible has demonstrated itself to be trustworthy time and time again. Modern science confirms it when we understand that. I hope that that's been clear this evening. We have some resources that I encourage you to get on this topic. Everything I covered is in this book, Creation Basics and Beyond. This is going to give you just the basics of these different fields of science, and some that I didn't cover, like astronomy, is in there as well. Was there an ice age, and what about continental drift, and how did dinosaurs fit into things, and how did Noah get all the animals on the ark, really? They're all covered in that book. It's written by all of our staff scientists at ICR. It's a great resource. If it looks too thick and intimidating, there's a student version as well. Yeah, it's called Guide to Creation Basics. So I think we have it as well. If not out here, we have it on our website. You can get a little cheaper here, though, because you don't have to pay shipping, and we'll absorb the sales tax here. Taking Back Astronomy, I didn't get to talk on my specialty topic, but if you want to see how the heavens declare God's glory and really strongly refute a Big Bang in billions of years, this is the book. This is what you want to get. The Ultimate Proof of Creation, you want to give a bulletproof argument for biblical creation that nobody can refute? This is it. It's going to show you how to think and how to debate the way Jesus did in his earthly ministry. And Jesus was very good at debating in his earthly ministry. He never lost one. And if you learn to think that way, you can achieve the same results. You're not going to be as good as Jesus, but you can be pretty good. Understanding Genesis. What about Christians who say, but those days might have been long ages and so on? How do I refute that? This book shows you that Genesis really does mean what it says, that those really are ordinary days. It's really a lesson on how to interpret Scripture, and it shows you that you can't really interpret Scripture any other way without doing damage to the text. Discerning truth, how to spot logical fallacies in arguments that evolutionists make. And that's an easy read. You could read that in an hour or two probably. But it's really just covering like the top 10 fallacies that evolutionists make in their reasoning, and like equivocation and things like that. And boy, that's helpful. When you're conversing with someone and they make a mistake in reasoning, you can very gently say, well, that's an equivocation fallacy, and let me tell you why that. I mean, you want to do it with gentleness and respect, but it's very powerful. You say, I don't have time to read? We got DVDs, okay? We've got The Created Cosmos. This is a fun one. This is the planetarium show that they show at the Creation Museum, one of them anyway. And I wrote this a number of years ago, and it takes you through the universe, and it's a lot of fun. It shows you how the universe declares God's glory. Some of my other presentations are on DVD as well, including The Secret Code of Creation, which is where I show how God has built beauty into fractals. And you got to get this one because it was filmed here, right? Yeah, so you got to get that one. And what else? Stargazer's Guide to the Night Sky. That's just a fun book on how to enjoy the night sky from a Christian perspective. And if you've ever wondered, what's that bright star over in the evening sky? It's Jupiter. And okay, can you see Saturn this time of year? Yes, you can. And it'll show you how to find it. And beautiful full-color star charts. If you're thinking of getting a telescope, it'll tell you what kind you might want to get, what to look for, how to use it, what you can see in it. And I just love that kind of stuff. The universe really declares God's glory, and it's a lot of fun to share that with others. Our dinosaur expert, Dr. Tim Clary, has written what I consider to be the best book on dinosaurs that I've ever read. It's fantastic, and we have some copies out there for you. This is one of our newer resources. And this is just a lot of fun. Adults will enjoy it. Kids will enjoy it too. It'll get a little thick for kids in some places, but they'll like the pictures. So and it's all from a biblical perspective, which is hard to get on the topics of dinosaurs and astronomy and things like that. Acts and Facts. How many of you are already getting Acts and Facts magazine? Okay, that's just a few of you. The rest of you need to repent and sign up for this. Okay, come on, I was here before. You should have all be signed up now. Acts and Facts is our free monthly magazine that's going to have faith-affirming articles that you can enjoy. And I've been going through a series on particles and how subatomic particles declare God's glory, which is something I don't think anybody's written about before. At least I haven't read anything like that. A lot of fun. And some of them are a little more technical, some of them a little less. So we have a variety in there for everybody. Check us out on the web, icr.org. And if you want to take a look at how articles write themselves, check out my blog. So thank you very much for having me out to speak. Do we want to do questions now?
At the beginning, you mentioned you had people looking through different lenses at the facts, different scientists, secular, Christians, brilliant men and women. One of the questions was, right to the heart, why do you believe that there are people who believe in evolution, those who are educated with the facts on both sides?
Oh, yeah, that's a great question. Why is it that these intelligent people believe in evolution? I got to tell you, most of them, I mean, there's different ways I can answer that. From a scientific perspective, most of them have not thought about it. I'm sorry, but most of them have not thought about it. Most of them are very ignorant of creation literature. I don't mean to be mean, but I watched the Ken Ham-Bill Nye debate, and I was astonished at how ignorant Bill Nye was of creation. He's trying to debate against something that he obviously hasn't read hardly at all. I mean, it's amazing. He lived near Mount St. Helens. I don't know how he could not know that stuff. A lot of them simply are not familiar with the literature. They haven't read up on it. They take it for granted because that's what they've been taught by people who take it for granted because that's what they've been taught. And so that is the view that's been legally enforced in most public education systems. And so people are brainwashed to believe that from a very young age. And very few people stop to consider and say, wait a minute, maybe what I've been taught is wrong. I think that's it. In terms of a scientific perspective. Now, we need to understand this is more than just an academic issue. There is a spiritual issue here too. And I would be remiss if I didn't mention that. Ultimately, people don't believe in God ultimately because of the hardness of their heart, because of their rebellious sin nature. And that's, we say, well, you shouldn't behave that way. Hey, if God hadn't opened my eyes, I'd be in exactly the same boat as they are. And that's why we can't ever have any arrogance to our friends who are unbelievers, because we'd be unbelievers too if God hadn't opened our eyes. And so it is a spiritual issue. If there's a God, if the Bible's true, you're accountable to that God for your sins, and that is uncomfortable for a lot of people who realize that God is rightly angry at them for their own sin. And so they tend to suppress that truth and unrighteousness. The Bible talks about that in Romans chapter 1, verses 18 through 20, how people suppress that truth and unrighteousness. They know God exists. They know He is who He says He is in the Scriptures, but they don't want to submit to that God. That's scary, to submit to that God. But the solution is not suppression. It's confession and repentance.
You've had conversations with unbelievers in your field. You went to a secular university, I believe, to study, right?
Yep.
So I have a couple of questions regarding that. Number one, have you had successful, in a sense, conversations where you've seen unbelievers who are scientists have a change of mind?
Yeah.
Where they've softened, even maybe converted? And then secondly, one of the questions I have here is, what's your favorite way to engage in discussion with an atheist or an evolutionist? Like how do you normally go about that? I'm sure there's different angles that you have, but so first question, have you seen them? So we understand, because there's some people here tonight who might be an unbeliever. Maybe you're skeptical and you're here checking things out and you're wondering, is there something to that?
Yeah, I've had a number of people who have. Usually the way it happens is they'll ask me a question. There's something that's preventing them from believing. There's some snare. There's some stumbling block, and they'll say, "Well, what?" It'll be something like radiometric dating. I remember one conversation I had with somebody about radiometric dating. That was the snag for him. I just don't know if I can trust the Bible because of the billions of years. Hasn't that been demonstrated? And I just went through the kind of like I did here. I went through and explained radiometric dating to him, and that satisfied him. He says, okay, that worked. And very quickly, he became a consistent young earth creationist, a Christian. And I have had conversations like that. And I've had others where they say, forget you, and walk off. And that's, it's not our job to convince people. It's up to the Holy Spirit to persuade them. I just give them the message. But I have had a number of people that have responded. And it's interesting, too. I've had people that I can tell that the Holy Spirit's working on them because they want to believe in God. The Holy Spirit is working on them. But there's some intellectual snag. And then if I can help remove that snag, I'll try and do that. And that's normally the way that I engage people. I tend not to be pushy. That's just not my style, I guess. I mean, we all have different ways of being used by God. But often I'll just put something out there, or asking questions is a great way to start a conversation. And a lot of times when I engage with people, it's at a situation like this, which is kind of unique because most of you won't get up and do a talk on creation. But a lot of times people will come up afterwards and chat a little bit. That's happened a lot. And sometimes it'll start the conversation going, and sometimes they'll follow up with email. And yeah, so the social media, it can be a drain, but it can also be a great place to witness. And I use it that way.
The majority of us don't have PhDs. Maybe there's some here tonight. Some of us don't read too much, extra, apologetic material. So I appreciate your encouragement when we're talking to an unbeliever. We're supposed to answer them in humility with gentleness, right? Never beating them over the head or trying to win the argument. And I appreciate that. How would you encourage just somebody like me, or most of the people perhaps tonight saying, like, how can I argue with somebody who's very well read, right, or does have a PhD? Do I run in the other direction and go get my PhD friend, or can I, with what I have, with what's been given to me by the Lord, talk to that person without fear?
Yeah, you should absolutely engage the person in conversation. Absolutely. Two things I would say. First of all, if you understand these basic things, most PhDs have not thought about this. I'm serious. Most of them haven't thought about it. They're thinking, well, we see small changes in organisms. Over time, couldn't that add up? That's the way they think about it. It's that simplistic. And you point out, wait a minute, now think about this. You'd have to add brand new instructions, wouldn't you? Yeah. But the process we observe remove instructions. They'll be baffled by that. Most of them haven't thought about that. It's astonishing. And so if you actually get like creation basics and beyond, like you said, most people are not going to go out and get a PhD. That's fine. God calls a few of us to do that, and we try to distill that down to a level that anybody can use. So that's the first thing. Most evolutionists are not aware of the evidence and or at least how creationists understand the evidence. And so you're going to have to point that out to them. And as long as you do it with gentleness and respect and ask questions and say, well, how do you see it? And then just when they give an answer that doesn't make sense, just ask them to explain that, and then. Really, you're just giving them enough rope, and eventually they'll hang themselves, honestly. I mean, that's really how it happens. And the second thing I'll point out is, so that would all be covered in Creation Basics and Beyond. The second thing I'll point out is if you, and I don't mean to be a big commercial, but if you get my book, The Ultimate Proof of Creation, what that's going to do is it's going to show you a way of debating with someone who is perhaps much smarter than you are, that they will not be able to answer. Because what it's going to do is it's going to show them that their entire field of study, whatever it is, would not make sense if biblical creation weren't true. And so somebody says, well, I'm a scientist. Well, that's great. Tell me, how would science be possible in the chance universe? How is it that, you're expecting to find patterns out in nature, but don't you believe that nature's just chance? Simple questions like that, and they'll have no idea how to answer that. And so I'd encourage you to get that book, Ultimate Proof of Creation. Take a look at my blog, too, just to see how I've interacted with them. I actually, that's another one that I do a lot on my blog. I haven't done it much lately. I don't keep up with as much as I should. But I've had a lot of interactions on my blog that kind of expose evolutionists and the way they tend to think and how I interact with them. And I try to be very gracious with them, but I don't let them get away with stuff either. If something's false, I'll point it out with graciousness. So anyone can do it. Anyone can do it. And Ultimate Proof of Creation is giving you that procedure that you can use on anyone. You can use it as my mentor on the topic, Dr. Bonson, liked to say. You can use it on the milkman. You can use it on a PhD philosopher. It doesn't matter. It will work because it's based on God's word is truth. And nobody can argue with God. That's what it comes down to.
Okay, so in that vein, and we'll wrap it up because we don't have too much more time. I had a couple questions come in that we just can't get to, but if you have those questions personally, you can ask Dr. Lisle afterwards. But the Bible. I've heard you speak before you were here last time, and your faith is in the Scripture. Mm-hmm. So why do some people, why we know why you say people believe in evolution over the Scripture. Why do you believe the Bible? And then secondly, for all of us here, what part does that play in your daily life? Because you're reading a lot, you're reading journals, periodicals, you're writing, you're engaging, you're a busy man in academia. Where does the Bible fit into your life and prayer, your devotional for all of us to be able to take from?
I believe the Bible ultimately, well, because the Holy Spirit opened my eyes to see the truth of it. God's hardwired us all to know that he exists and that he is who he claims he is. And when we read his word, it rings true. But in terms of a rational perspective, why is it that rationally, what is my rational justification for believing in Scripture? The answer is itself scriptural. The fear of the Lord is the beginning of knowledge. In order for us to know anything about the universe would have to be the way the Bible says it is. The universe would have to be organized by God, so it would have order in it, patterns to understand. My senses would have to be basically reliable. I mean, I couldn't know anything if I didn't trust my senses, right? If I said, well, yeah, I see all of you, but that just could be holograms. Or I could just be a brain in a jar with inputs fed in like that. I trust that my senses are reliable. But on an evolutionary worldview, why would my senses be reliable if they're just the results of mutations and natural selection? You see, and they might have survival value, but that doesn't make them reliable in the sense of truthfully communicating about the universe, right? In order for knowledge to be possible, the Bible has to be true. That's a simple argument. There's more I could. I mean, if that's the first time you've heard that, you're thinking, boy, I don't know. That's a very powerful argument. You just have to really think through the implications of that. And in fact, one of the conversations I had on my blog, I ended up saying, for all you know, you could be a mud puddle on a distant planet. How do you know that you're even having this conversation with me right now? And he could not give an answer to it. He tried several different times, and I would shoot those down, and I would say, no, that doesn't work, that doesn't work. But from an evolutionary perspective, you can't know anything. You couldn't even know that you're here having a conversation with me, I pointed out. The idea that we're able to think rationally, well, that's because I'm made in the image of God. God's rational, and he's made me in his image. Of course I can think, which means I can consider the options and choose the one that's the best, that's the most rational. But if my brain's just chemistry, well, chemistry just does what chemistry does, right? There's no thinking about it. There's no consciousness in chemistry. There's no choice in chemistry either. And so all of these things, or morality for that matter, how can we make sense of the fact that there is a moral code that we're all supposed to obey, and who decides what that is? And even the most ardent secularist does believe in some kind of morality. They might say, oh, no, morality can be different for different people. Really? What if I want to shoot you right now? Would that be okay? If my morality says that's okay, would it be okay? He'll change his mind very quick if I pull that on him, right? And so my rational justification for believing the Bible is that it provides the foundation for knowledge for everything else. No other system will do that. Secularism won't do that. No other religious view will do that. Buddhism won't do that. Hinduism won't do that. The Quran won't do that. Okay, only the Bible provides the foundation for knowledge. And that, again, is spelled out. I know that's deep, but it's spelled out in detail in my book, The Ultimate Proof of Creation. How do I use this in my daily life? Well, the more I study God's Word, the more I think about God, the more I realize that the biblical worldview should be foundational to everything I do in my life. Everything. And so I try to do everything that I do to the best of my ability. I want to do it so that it glorifies God. Even when I make presentations like this, I try to make them I'm not an artist, but I try to make them as attractive as I can so that they look professional and they're God-honoring. Everything I do is to glorify him, because I believe that that's my purpose in life. I believe that's our purpose of all of us, is to glorify God and enjoy him forever. That's the purpose of man. And that's why we're here on this planet. So that affects every aspect of our lives. It doesn't mean that you can't goof off and have fun every now and then. Of course you can. But that's part of, you can enjoy that with the Lord as well. But everything we do ought to have a purpose and meaning. And so I don't know how else to answer that other than that.
Okay, so I think one of the things I'm pulling away from this, and hopefully everybody else, is whatever you're called to, whether you're a PhD, you're going around and you're speaking about creation, whatever you're called to, a doctor, a lawyer, a plumber, a pastor. You don't have to be a pastor to be somebody who's ministering the Word of God in the Word of God. What God's given to you is your spiritual act of worship. Yeah. And so what you do. So two things. I have one question about the young person who would be going to school, and then I have just one question for you to the unbeliever tonight. First, if you are a young person in the church preparing to go to university, especially those interested in the sciences, what would you say to that young person?
Okay, I would say we are here for you. That's kind of where my heart is more than anybody else. I have a real heart for students who go off to college and they get brainwashed into believing that science somehow supports evolution, and they walk away from the church, and that breaks my heart because it's so ridiculous, and intellectually it's just absurd. And so I'd encourage them to get involved on our website. Our website has thousands of free articles. I know students can't afford much, so the website's free. Check it out. The one book, Get the Ultimate Proof of Creation. That honestly, that's going to train you how to think, so that no matter what professor you get, you can spot errors versus truth, and even discerning truth also. Those books would be very helpful. I have an article that I wrote for our sister ministry, Answers in Genesis, on how to survive secular college. I would encourage you to look at that as well. And that's more than I can say in just a few minutes. But there are some real key things that you need to do to survive in college if you're a Christian, and especially if you're going into science. You're going to have to work harder than the folks who are secularists. But God didn't call us to an easy life. He called us to be Christians, and He died for us. So anything that we do for Him is less than what He's done for us. And I would say be very solid in the Word. Just make sure you're always studying Scripture, and being part of a local church that is Bible affirming. You need other people that believe the Bible to encourage you.
Last question. There could be some tonight who don't believe. They're here genuinely wanting to know. What would be the first step or two that you would offer them towards truth? If God is there, if Jesus really is the Son of God, if being a Christian is the way, I do want to know. Mm-hmm. What would you say to them?
Yeah, I would say that, first of all, according to God, you already do know in your heart of hearts. You do know that. And you may have spent a long time suppressing that truth and unrighteousness. We all did that before we got saved. We were suppressing the truth and unrighteousness, and if God didn't open our eyes, we'd still be in that way. And the bad news is God indicates that you can't even repent apart from His power, which is kind of interesting. Paul talks about that God may grant them repentance. That's a strange phrase, and it bothers me, but it's in the Scriptures, so I have to take it seriously. The Holy Spirit has to enable us to repent, and so I would say to unbelievers, in your heart of hearts that there's a moral code that's binding on all of us, and that only makes sense if there's a biblical God. If we're just rearranged pawn scum, morality makes no sense, right? I mean, chemistry just does what chemistry does. There's no right or wrong about it. You baking soda and the vinegar and it fizzes up, that's not right or wrong. You don't say bad baking soda. You shouldn't have done that. That was wrong, right? It's what happens. What happens with chemistry just happens. And that's not the case because God's hardwired that knowledge into you of Himself. You know that you're made with a purpose. And so immediately you should know that there's a God that you violated His moral code because you know what right and wrong is. He's written that law in His heart, so you violated that moral code. But the good news is the God of Scripture, the one who makes knowledge possible, the one who's real, the one who created the universe, is willing to pay for your sins. If you would trust in Him, if you would repent of your sins and confess Him as Lord and Savior, He'll be willing to save you. I would encourage you to check out our website and see how all these lines of scientific evidence confirm what the Bible teaches. And I'd encourage you, even before you do that, some people say, well, I need to have all these intellectual objections satisfied, and then I'll believe. Well, God's infinite, and so there are always going to be things about Him you don't understand. But the Christian worldview does make sense, and it is rational, and it is something that's confirmed by science. And so I would, don't wait to repent and trust in God. I would say do that immediately, and then follow up by seeing how the Bible has been confirmed historically and scientifically and so on.
Thank you, Dr. Lisle. Thank you for coming.